C3, transforming graphs of functions. Example 8. We're solving a modulus equation. That equation is the modulus of 2x take 3 over 2 equals 3. Now graphically, here's what's going on here. I've drawn the graph of y equals the modulus of 2x take 3 over 2. Where would it equal 3? Well, that's where the y values on the graph would be 3. So on this graph, it crosses the y-axis at 3 over 2, which is 1.5. So y will be 3 approximately up here. What I'm doing now is drawing the graph of y equals 3, which is a horizontal line, of course. So you can see we're expecting two solutions to this. Two places on this graph where y is 3. Now we could now write down two equations by looking at this graph and considering whether the graph has been reflected or not reflected. However, I'm going to use a slightly different method. It's the same maths in the end, just a different way of thinking about it. I'm going to look at what's inside the modulus signs and think about what does it equal. Modulus of something equals 3. Modulus of something equals 3. What can we conclude about the something? Well, it must have been 3 or minus 3 inside the modulus for it to have a final value of 3. This means the numbers inside the modulus, in this case 2x take 3 over 2, must equal 3 or minus 3. So let's write those as two separate equations. And I'm going to solve them separately, and they will give me the two solutions that we can see we are expecting from the graph. So this left-hand equation, 2x equals 3 plus 3 over 2, which is 9 over 2, and then divide both sides by 2, and we get x is 9 quarters, or 2.25. So that will be this solution on the graph. Now the other one, 2x equals minus 3, and then I'm going to add 3 over 2 to both sides. So now I'll have minus 3 over 2 on the right hand side. Dividing both sides by 2, and I get x is minus 3 quarters, and that would be the negative solution we were expecting. So there's the two solutions to this equation. And you can check if they are correct by substituting them back into the original question. And if the equation works, then you know they're right. And that's a good thing to do in an exam.